Welcome. In this lesson, we will apply the concepts that we learned in previous video about critical points, first derivative test and second derivative test, and this fundamental problem we solve it. We'll apply this to some simple uh, basic like optimization problem and see how these how we can make use of what we learned in the previous thing. Like, and again, this course mainly about like fundamental basic concepts and fundamental problems, but sometimes I might give you something, a little bit of thinking. I mean, not much thinking, a little bit of thinking, yeah, and problem solving. But usually, most of what we do is just direct application of the rules or like the equations that we have. But let's do something like this, yeah. And again, in the exam, I will not give you something that you didn't do, that you didn't practice well, yeah. So I will, if you something you didn't practice well, you will not find it in the exam, and you will also not find it in the homework, yeah. Or the homework is just like one additional practice, okay. So let's just start, yeah. So like a farmer want to fence a rectangular field that is adjacent by a river. Okay, so you have a river here, and the farmer want to fence like a field here, yeah. The side along the river does not need fencing, so I don't need to fence this guy here. The field must, so I basically need to fence like this guy here. Yeah, this guy here, this guy here. So I have like this width here, I have this width here, and I have this length here. Yeah. Sorry, it does not look very rectangular. My bad drawing. Yeah. Anyway, uh, so this is subject to a constraint that like all the area, so all the area should be like 12,000 meters square. So the area again, that would be like length times width. So the length times the width, they should be like 12,000 meters square. Yeah. The cost, like each of these guys, like each meter, they cost like $10 per $10 per meter. Yeah. So the farmer want to minimize the cost of fencing. So like this in optimization, we call this like this. So this is similar. Like this is a typical minimization problem. So I want to find like the L and the W that will give me the minimum cost, provided that I get like this total area, 1200 meters squared. Yeah. So we like so this like let me write this in optimization language. So they use this jargon like objective function. So let's write down the objective function. So what is the objective function? So the objective function is like my cost, yeah, that is equal to 10 times the length plus 2w. Yeah, that's like my objective function. This is like subject 2. Subject 2 is that I want my L and W be equal to this guy here. And okay, so can we do this? So basically, what is the L and W that will give us the minimum C? So I have like a function. C is a function of L and W, and what is the L and W that will give us C? In all the previous problem that we solved, we only have one of these like independent variable, like only one variable, like X, not like two of them. Here we have two of them. We will like learn multi-variable derivative, like that is like a in another lesson. But for now, let's just, here now we know a relationship between L and W, so we can just get rid of one of them and just have one variable, one independent variable, which is like W or L. So let's get rid of the L, yeah? So I can say like L is equal to 1200 over W, yeah? So here, my objective function would look something like this, like I will like 1200 over W plus 2W. So here that would be 12,000. I'll bring this guy up, minus 1 plus 20W multiplied here. Okay, so now this is looks nicer. So now I'm telling you what is the W that will, so I have C as a function of W, so you have here C as a function of W, yeah? And I'm telling you what is the W that will give me the minimum C. And we know this, that we, like how to do this, we just find like the derivative of this guy. So basically like that is like dC over dW. And when like simply we just can write it like this, yeah. When this guy is equal to 0, that will give us the critical points. And this critical point, we can just use the second derivative to find like the minimum, local minimum, yes? That's basically how to solve it. So basically like to solve this, we need to find like this guy and we need to find like this guy. That's like the second derivative, yeah? Yeah, so can we do it? Yes, we can do it. Yeah, so you find the first derivative. So that would be minus 1 here. So that would be minus 1200 W minus 2 plus 20. The second derivative, you multiply this guy here. So that would be 24, 1, 2, 3 W. You subtract 1 from here, minus 3. That would be plus 0. So that would be like my second derivative. Let me put this guy here. Yeah, do you agree? Okay. Okay, so I am almost done, yeah? Because like, what do I need to do? Yeah, I know that like to find critical point, that is when C is equal to 0. So basically I got this guy and make it equal to 0. So I got like negative 12,000 W minus, maybe put this guy like W square, yeah? Plus 20, that is equal to 0, yeah? So what does this mean? So this means that I can say, I can like put this guy here and then multiply this W, so I can say minus 1200 is equal to minus 20 W square, yeah? And can I get rid of this guy and this guy and this guy and this guy and like this guy and this guy? So I get here W2 will be equal to 600, yeah? So what is W? Like we can, so W is equal to square root of 600. And I can do like maybe some algebraic trick. Like, can I do this? So that's like 1000 times 6. And the square root of 1000, that's like what? That's 10, yeah? So W would be like 10 to the square root of 6, yeah? Just some tricks, yeah? So now I got W. If I got W, I can get the length easily because I know that length times W is equal to something like this. So what would be the length? So the length would be this guy over W. So that would be like this guy over this guy to this guy. And that would be what? So like this guy will go away with these guys, yeah? So I got like 6, oh, sorry, 10 here. This guy go away with this guy. So I got like 120 over square root of 6. So can I do some algebraic trick here? Yes, I can. So I can say, let's try this, yeah? I can say what is like 20 times 6. I can do like 20 times 6 over, because 20 times 6, that's 100, yeah, over square root of 6. So this could give me, that is like equivalent to, like this is square, yeah, because like this guy, like this is square. So this guy will go away with this guy. Then I got 20 times root 6, yeah. So here I got like L is equal to 20 root 6. Okay, so basically, now I want to see what is the minimum cost. If I want to see what is the minimum cost, basically I substitute these guys in my original equation here. So C is equal to 10 L plus 2 W. Yeah, did I get this correct? Yeah, L10. So basically, this at this width and this length, that's where I will get the minimum cost. So I can substitute this guy here. So this is like 10 times L, that is like 20, this, and then like 2 times W, so that's like plus 20 square root of 6. So, yeah. So I can take like this guy as a common factor. So that would be like 10 times 20, that's like 200 square root of 6. And then this guy, so that's like 2, so that's like 400 square root of 6. Yeah. And then you can use your calculator to estimate this guy. And it's like 400 times square root of 6. That will give something like this. Yeah. Okay. So the cost, like if you make W is equal to this number, L is equal, length is equal to this number, that will give you the minimum cost at about like $1,000. Yeah, that's basically how to solve these type of problems. Yeah. What else do we have? I think that's like a, simple, like this is a practice problem. So like the practice problem, I will solve it in the tutorial, and tutorials are optional. You don't need to watch them. So if you can, so basically like try to do this on your own, like pause this video, try to solve this problem on your own, see where you're gonna get. That's how you learn. Like if you kept watching these videos without really getting your hand wet, you're not gonna learn much. Yeah. So basically like to learn this thing, you need to start solving this in your own. If you cannot solve it, then you can check the solution. So here I provided like the solution for you here, but don't look at it. Like first try to solve it on your own and then get to the solution. Now, last thing I would like to go over is like your homework problem. I know again, like these type of like critical thinking problem where you have to think, some of you might like struggle with it because you haven't been doing this for some time, or yeah. But that's okay. That's fine. Like I try to give you like easy homework. Everything in this course is easy, yes. And let me just try to give you like some hints. It's very straightforward, but like just for those of you who might struggle, I will just like give you some hints. So here, a manufacturer want to design an open rectangular box with a square base to minimize cost of material. So open rectangular box. So here, let's say like I have a box here. Yeah. I have a box here. And it's open from the top. Yeah. Imagine this is a box, like sadly looking box. Yeah. The box must have a volume. So now here the volume must be like 1000 centimeter cube. The cost of the material for the base is $20 per centimeter. So here's the cost of material here, like for the base is $20 per centimeter cube. And for the sides, like, so we have like one base, it's open from the top. So here, this is like open here. It only like this is open, has one base and four sides, like 1, 2, 3, 4 sides, yeah, and one base. So for the sides, the cost is $10 per centimeter cube. Yeah. Find the the box must have volume, the cost of the material of the base, the cost of the material of the side. Find the dimension of the box, length of the base, width of the base, and height to maximize cost. So the base is square. So the square base. So that's why we have L and L. So that's like L. Yeah, that is L, and that is the height here. You have like the height here. So this is L, and this is the height. So how to solve something like this? So I want to minimize the cost. So again, like you write like objective function. That's what you do. You write like an objective function. And what is your objective function? Like again, this is the cost. Like what is the cost equal to? So the cost, that would be the cost of the base, yeah, plus the four sides. So I know the base, that would be like 20 times like L square, yeah, that's like L square because that's a square. Yeah? The base should be square. Uh, and the cost of the four sides. So here I have like four of them, and the cost of each one is like 10. And so I have like four of them, and this would be like each one of them is L times H. That's the area of each one, L times H. So basically I get something that looks like this, and this is like subject 2. So my volume here, that is like what? LL times H, so subject 2. So this is the volume, like, so that would be like length square times height is equal to 1,000, yeah? Do you agree? That would be equal to 1,000. So what do we do? Let's get rid here of the h, yeah? So we can get rid of the h, so we can say like h is equal to something like this. Yeah, do you agree? Over L square, yeah? That's like get rid of the h, yeah? So what can we do here? So what we can do here, yeah, is basically like substitute this guy and get rid of this guy. So we can say like the cost is equal to 20 L square 4 plus 40, and then here L time 1,000 over L square. Yeah. So basically like, oops. So this guy will go away with this guy. Yeah. So basically I can see like my cost is equal to 20. Yeah. L square plus I multiply this like 40 on to 3,000, and then I can bring this guy up L minus 1. Yeah. So basically that is my objective function. So I helped you by developing the objective functions. The rest, it should be like easy for you to do, because remember, like, what are the next step? Oh, one thing I think I forgot to mention here. Here, actually, I didn't use the second derivative. I just assumed, which is okay. I just assumed that like the critical point that I got was like already a negative, a minimum. And but this is obvious because let's like here, this is our second derivative test. Yeah. Remember, you like this is like, let's say, what critical point did I get here in this problem? Yeah. So let's do. So here, this. Let me write it here. That is equal. I never use this one. I forgot to use it, but that is obvious because this is like W cube, yeah? What W did I get? Like what critical point? Like when I solve it for this guy, I got W is equal to 10 to the power of 6. What does this mean? So like if I substituted this here, I will definitely like, so basically like that is like C to my critical point, so which is 10 to the power minus 6. So basically that's like 24,000 over 10 to the power minus 6 to the power cube. This is like larger than 0, which means that this is a minimum point, minimum critical point. Yeah, this is a minimum point. I forgot to use it, but that's basically how you can use this second derivative. But we didn't need it anyway because we only got 1 point and we know that this is a minimum point anyway. So let's just continue here with your homework problem. So here what do you do? Like you find like we know that in order to find to minimize this, like we want to find like which L, what is the value of L that will give us the minimum cost. Like, and we know to do this, that is when C is equal to 0. So basically, like what you do here, you find your first derivative, you find your second derivative, like your first derivative, whatever you get here, you make it equal to 0. So whatever you get here, you make it equal to 0. And then once you do this, you solve for L. Once you know L, then that's easy. You can substitute here. Like once you know L, you can substitute here and you get H. Yeah. And once you know L and H, you can substitute in your cost function to find like the minimum cost. Yeah. If you want to check that this point, like this L value that you got, like is local minimum or not, you basically substitute it here, like in your second derivative, and for sure, if you like substitute whatever value, let's say, like just say for the sake of argument, so L here, like that would be the multiple choice that I will give you, for example. So L here could be like 5, it could be like 10, it could be 15, it could be 20. Yeah? That could be L. Then you substitute it here, like in this guy, and then you will get H. Yeah? Let's say H could be equal to, again, 5, 10, 15, or 20, something like this. Yeah. And then if you like if you checked like C at L, like at 5, for example, or 10 or whatever, that for sure will be like larger than 0, meaning that this is like a minimum point. Yeah. Okay. So basically, I'm not solving it for you. I'm just like giving you some hints. I'm not gonna give you any more hints beyond this because I almost like solved the problem for you. Just please look at the example that I provided. If you need additional help, please look at the tutorial videos that I will make. But I'm not gonna answer any more question about this homework because otherwise I will really solve it for you here because the rest is very simple. Okay. Okay, so that is it for this lesson, and see you like in the next video. We will see like how these we will see. Oops, what happened? In the next video, we will see uh, some like explore some of the practical application of these like optimization method. Like we will learn more about optimization and see like how to formulate like objective function for real life problems. I will show you this for a groundwater remediation problem, and then I will show you how to use like derivative based stochastic and meter heuristic like to calibrate a model like a groundwater model. But again, we're not gonna go into details like hand-on detail, like this hand-on detail and like doing projects or about these things that would be in other courses like groundwater hydrology, for example, or groundwater modeling or whatever. Yeah, the specialized course is that's where you will get like this hands-on experience how to build this model and how to use them for your management purposes. Yeah, but not in this course. This course mainly emphasize the basic and fundamental principle and fundamental skills.